Welcome in this session where I tell you about a few features in OpenJDK 17 which are not related to those language features like records and text blocks, but what is also very interesting and are also a good indication for moving to that new version because you can benefit from it in that latest release. So, as I mentioned, not going to talk about those things in red here, which are very useful in JDK 17, like records and text blocks or that helpful null pointer exception messages. But I'm going to talk more about the things in green, which are also very important, but not immediately related to what a developer does. For instance, the new garbage collections and the performance that you can achieve with them. The class data sharing to get a fast startup of your application has become easier. And you also have something like the deserialization filters to mitigate some vulnerabilities with the Java serialization process. So I'm Rudy de Busscher. I'm working for Payara as a product manager and developer advocate, doing presentations like this one, but I'm also involved in the Java enterprise world with the micro profile and the Jakarta EE specifications. So what are the changes from JDK 11 to 17? A quick overview, but most of them you know, the developer ones. But I'm going then to focus more on that class data sharing, where you can have easier usage now with the commands became easier. A few words about the garbage collection, the new collectors which are added in the recent versions, and the performance improvements that you can achieve with it without changing your application, of course. So it's just a configuration setting. So a flight recorder is now also available for monitoring purposes and not only for finding issues and seeing what is going on within the JVM. So I'll have a quick look at that option too. And then as mentioned, for the security related aspect with that deserialization filters. This information you should already know that JDK 17 is the current latest long-term supported version, so it will not be replaced in 6 months, but there will be regularly updates around bug fixings and improvements done on the JVM itself, but the functionality stays stable, so it is a good version to get started with, especially in enterprise worlds where you have the requirement of a bit more stable environment in most cases. And so the previous version was LTS, was JDK 11. Now it will not be 3 years, so the next one will be in 2 years. So it will be JDK 21, which is the upcoming LTS version in 2 years. And as mentioned, there are many changes, but on very different levels. The Java language changes, but also some JVM changes like those garbage collectors and some operational aspects. Those class data sharing options are easier to use now. Is the switch, what I mentioned, from JDK 11 to JDK 17 a difficult one, as like we had in the case with JDK 8 to 11? Well, no. This time there are, as mentioned, a lot of new things, but stepping from JDK 11 to 17 now will be an easy one. The main difficulty here can be that some of those internals are again shielded off more. So even if you are running on the class path, some of the classes or packages are now shielded off. That was already going on since the JDK 9 and the modularization. Again, few of those things are now more encapsulated, so you can have the issue that your application is no longer working because it was using those, so that you need to find a replacement or because they are always there. But other than that, if you are running on JDK 11, it should be easy to switch to JDK 17 and use the benefits from the new language features, but also the benefits in improved performance and usage. These are the language features. They are discussed already several times. You see a lot of examples for them on the internet, so I'm not going to talk about those in this presentation, but I want to talk more about those operations-oriented changes, like the changes in garbage collectors, that CDS archive and that dynamic CDS archive, which is implemented, the flight recorder for monitoring, and things that I are not covering but are also interesting is the support for that new processor architecture in Java, but also a packaging tool so that you can, for instance, create a installer for a specific operating system for installing client-based tools and applications that you build. So first, we have a look at the class data sharing. The idea of that feature is that you have a faster startup. So by preparing all the class information, I'm not going into detail. There is already some information available on how class data sharing works. But in one sentence, it makes your application start much faster because the classes are the class data and metadata are already prepared in the format that is required by the JVM itself for immediately using it at runtime. So all the class loading or most of the class loading is bypassed and it can immediately use that information. With JDK 11, that was still a two-step process. And the first step, you needed to determine or prepare a list of all the classes that you want to have in that archive file, so that are properly prepared for the JVM. And then in the second step, you need to create the actual archive file itself. Here it's called the payara.jsa file because I'm going to use it with Payara Micro in this example. And in this second step, the information is prepared so that the JVM can use it immediately. This two-step process works well, but of course is a bit cumbersome, and especially that second step took quite some time. So now in JDK 17, you have the option of what's called a dynamic archive. And since the JVM has all the information at runtime already available of all the classes of all is there, so why don't we just dump that information from a running JVM so that you have that archive file class there? So actually you do not have any additional preparation step anymore. It is created, that archive file is created based on a live environment, so it is very accurate also. So there is only one command now required that here is with the archive classes at exit. And so when the JVM exits, that archive file is created. And with Payara Micro, we have there a specific support for this kind of warm-up strategies with the warm-up option here that instructs the Payara Micro process to stop when everything is loaded, including your application, and everything is ready. And with that minus warm-up there, the JVM exit, and due to that option archive classes at exit, of course, then the archive file is written at that moment. So there is no separate step anymore of defining and then creating that archive file, which is much easier then, of course. So let us have a look and see how that works with the example that I have prepared. So I have here a Java version available. It is a Azul JDK 17 version. So first of all, let's see how the Payara Micro application starts up with your application loaded without any changes. So in the classical sense, we started up with Java -jar We specify the jar file which contains the launcher. We describe the location of the deployment directory where our application is located, and we indicate that we don't need any clustering capabilities of the Payara Micro. The entire process starts up, and at the end it shows us the endpoints, but more importantly here it shows that the startup was performed in around 6.7 seconds. So let us see how we can now improve that with that class data sharing option. So for that I'm creating a command where I specify that archive classes at exit, as I showed you on the slide, where we indicate the file, the .jsa file. We again specify the same launch parameters that for Payara Micro. We indicate here warm-up that it is that it will stop after everything is uploaded, is started, and due to that exit, then the archive file is written and can be used in a subsequent run file. So again, it starts up the same as you saw previously, and now here he is already writing down the file. There are some warnings that some older files are not available in that archive file, and if we have a look of what it has created now, you see here that the archive file is created, that it is purely read-only for all users, that's the ID, so that you cannot tamper with it, that you cannot mischange it, and the size is around 72 megabyte, so it's a bit smaller than the original jar file. So now that we have that archive file, we can start Payara Micro using that archive file. And we still need to point to that launcher jar file here, because as you have seen, there are some classes which are not included in that archive file, so it needs to load and those in the classical sense, but there is no options needed to specify because all that information is already available in that archive file. And then when you start it up, you see now that the startup is faster, that we have gained some time in startup. So if you have the case that the startup time is critical for your application, then this CDS option, and now with that dynamic archive, that the archive file is created at the end of the process of when the JVM exits, then of course that is a good solution because you don't need to rewrite your application or change to a different runtime. The next feature that I want to discuss with JDK 17 is the garbage collectors. There are a few new garbage collectors now available. They have been developed over various versions, but they are now ready for general usage, if you ask me. These Shenandoah and ZGC collectors are designed with an ultra-low pause time, so they do not stop the execution of your application for a long time. And most of the functionality of the garbage collector runs concurrently with your Java statement execution. So they don't interact, and that means then, of course, that you have a higher performance because you don't need to stop the execution of your Java program. There are two implementations that work based on that same principle as Shenandoah and ZGC. As that ZGC or zero garbage collection actually performs some garbage collection. It is not that it does not do any cleanup like the Epsilon garbage collection, which just performs the memory allocation, but that ZGC also cleans up and is usable for a general purpose application that runs a long time. It can even be used with a very large heap size, and even in that case, the pause time is very short, so that's a good candidate there. The Shenandoah is probably a bit more suited for smaller heap sizes and not that terabyte sizes, but both perform very well. So how do you choose which one is the optimal, or maybe you can stick with the standard G1 garbage collection? So to find out that, you need to of course experiment, because each application is a bit different. Each application has a different pattern in using the memory, creating, cleaning it up, etc. So you need to experiment to find out what is the ideal throughput and latency. Throughput is the amount, the percentage of the time that your application is running in relation to the total time, and the latency is the maximum wait time for each pause. Those two parameters can give you an indication which collector is the best, and that is something that you have to find out through some experiments with your application. But even with the classic G1 garbage collector, there you can achieve some good improvements. So I made a comparison where I used the same PyArmicro binary again. So it was not optimized for JDK 11 or 17. I only assigned a very small heap size, 256 megabyte, and it is running the same application in both situations, which uses a lot of CPU and memory, that application. If I run that on JDK 11 and 17 and compare the results there, then you can see on the right that the graphs indicates that on JDK 11 there was the execution was around 110 at the average one, and with the JDK 17 it was around 90. So you see that there is a real improvement of the execution of the application, in this case with JDK 17. Of course, again, that depends on the type of application, and probably the changes are here that high, that's significant due to the type of application and the small size of heap that I assigned. But as you can see, even with the same application, you can benefit from switching from JDK 11 to JDK 17. The next topic that I want to cover is the uses of the flight recorder. For those that already use the flight recorder, most of the time you use it for diagnostics, for profiling, to see what is going on within the JVM itself. But now you can also use it for monitoring, because you have something which is called the flight recorder event streaming. The flight recorder, if you use it in a classical way for diagnostic, then it collects all the events, it buffers them in memory, then later on it buffers it on the disk itself, so in what's called in a repository, and then if you request it, or if there is for instance a unexpected exit of the JVM, the file can be written with all the events of the last X number of minutes, for example. But now with that event stream, we can listen to the in-memory buffer. So our application itself can listen to the events that are emitted by the JVM running your application. You can also listen to that repository if you want to have an application out of process, if you want to have a separate application that listens to all those events. And then you can act on certain type events. For instance, as you will see in the example, we will act on the garbage collection events. And you might react on those, for instance, that your application itself performs some changes, where uses the memory will start using the JVM in a different way based on some of those events. So this is the graphical way what I explained. So all the events which are generated by all the different subsystems of the JVM, first of all, they are buffered in memory. You can listen there from within your application to this global in-memory buffer, or when it is in the repository in a directory. So in that case, you can have another another Java program listen to these events here written in that repository and act upon it. So in the example here, I'm going to show you how you can listen to all the garbage collection events For the example with the flight recorder and streaming, I'm going to launch the same application that I used for comparing the performance there on the G1 garbage collector. So I'm launching a application with only 256 megabyte of memory, so that you can see that I can capture the garbage collection events through the flight recorder in a separate program. So that is now running. So I have created a short script that's called configure the flight recorder streaming. It finds the program ID of that Payara micro that we have started. And then it configures two options. One option of the flight recorder at that repository path where the events are stored on disk. And I start immediately a flight recorder session. So when I run that, it is executing, so it captures events. And then in a separate program, so this is just a plain Java 17 program then with a main class, I can just say event stream, open that repository that I have configured there, and I'm going to listen on, in this case, only the garbage collection, but of course I can listen on any event like CPU load or other ones. I start that program. It starts up, but since there are no garbage collection events triggered, I don't see any output. So then when I perform here a curl command to that endpoint, which initiates a lot of CPU and memory, you use it, you see that each event is here listed here in that separate program because I'm listening to that repository, and I get information about the duration and all that information is here available within that event. The last topic in this presentation will handle then those context-specific deserialization filters that I mentioned. So the one of the important changes for security in JDK 17. We all know the Java serialization and deserialization, where we can write the content of the Java instances, the Java objects to disk in a binary format, and can read it later on again if we need it. If we are creating a custom serialization, so with that read object method, the fact is that the read object is executed immediately, as you will see, before any of your Java statements are executed. So you don't have any control over what is read, what is deserialized, and if the original content is replaced by some malicious content, that when you deserialize it, it will execute something which you do not want, like looking at passwords or looking at what is your disk, then of course you have a security vulnerability. That will only happen if you have a combination of certain classes, certain frameworks, etc. But there are people and even programs specialized in finding what's called those gadget chains, so that they can construct such a serialization as such a serialized content that when you read it, then you have some vulnerability and you have some exposure of your data within your system, for example. Now with the JDK 17 LTS, there is now available a new option so that you can allow filtering on the very low level, filtering on what is read from that deserialized content. But you can also use a system property, JDK.serial filter, to define what is allowed and what is rejected. So let us see as an example, then all those things become clear. So let us first start with a simple example where everything is behaving normally. I'm having here a record. At least I should have something about those language features in my example. So I have a record where I can store some information, and when I can serialize and deserialize that to a certain file. Serialization is done the classic way with an object output stream and reading again with an object input stream, where I cast that to the correct type and I do a print out, for instance. Running that example, then I serialize the content to disk and read it again, and I see that I get again the correct values that I've put there as initial value. But if you are using something like a gadget or such a gadget chain, and this example is based on some code that's provided by Sneak, so they are doing wonderful things related to security. And here I have a gadget which contains a runnable, a command that is actually runnable. So in that read object here, which I specified specifically for the system that it needs to use this method when it reads the content of a serialized stream, then I can immediately run that command. And then when I, for instance, specify that that command needs to list the directory content, then although that gadget is not here, it can't read DTO, so this line will fail, but you will see that that read object is already executed and the harmful execution is already performed. Before that class cast exception, you see here the contents of that directory where I'm running this program. So that is, of course, not a good thing, and that's a cause of many of those issues which you have with the Java serialization. But there is, of course, a safe way where we have here that same gadget, but now I'm using that new method here, the allow filter, and that object input filter, where I say that everything within the package that or in the sub packages where my program is located, that is allowed, but everything else is rejected. But of course that does fix some things, like it will stop that some arbitrary gadgets are injected in that serialized stream. But if you have a case where, as in this example, that you have that gadget and that command within your program, but you still want to make sure that you have some kind of control, and then you need to do something additionally. So we set already that filter, so that only packages within our application are accepted and the rest is rejected. But we also define that we is some kind of merging. If we have defined later on additional filters, we merge the filter with this global filter. And here in the deserialization, I then explicitly say that that gadget class is rejected and all the rest is undecided, and then goes to that other filter and will end up here a check on the package name. So closing this, clearing this for clarity, when I run now the program with my additional filters here, which I have defined, then you clearly can see that I get an exception, but much earlier now, I get an exception that my content and my payload is rejected. And you can see that the listing of the directory is no longer happening. So this additional configuration with that allow filter here and reject filter effectively makes sure that I can stop such malicious content. But it does not hinder the normal you use it. So if I again create a file with proper content with that country DTO, you see my filter allows it, and then I get that information here in the output. So thank you for joining me in this session. And if you have any questions, then please ask them now in the Q&A part of this session. And if not, thank you and see you. Bye.